Let's begin with an example that I'm sure many of you have seen before, although if not, that's perfectly okay too. I apologize for the sound of my voice. I do appear to be losing it, which is okay. Let's think about the example 6 times 3 to begin. First, I will draw this as a set of flowers. And I'm going to begin by drawing a flower with this many petals on it. So here's the flower. Here's the middle part of that flower where the petals come out of. Decisions. What color will the flower be? Let's go with this. 1 petal, 2 petals, 3 petals. Not my best work, but that's okay. We're just getting started. This flower has 3 petals on it. Now I can look at my first number here, and that's going to tell me the number of flowers that I'm going to draw. This second number, in this example 3, told me how many petals on 1 flower. And the first factor in our multiplication problem, both of these numbers are called factors because we are multiplying them together. This first number is going to tell me the number of petals, the number of flowers. How many flowers? So in this case, I have to draw 6 flowers. I've drawn 1 so far, so let me draw some more. If I have 1, 2, 3, 4, 5, 6. And remember, my flowers have 3 petals on them, so that's what I'm going to draw on each. Oh, here they are. Okay. The answer to this division problem, just kidding. The answer to this multiplication problem is the total number of petals. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 petals, which is one way that I know that 6 times 3 is equal to 18. If you've seen any of my videos before, you may have seen me do multiplication, division, or any other number of math problems using flowers. But you may have also seen me do problems using caterpillars. That's my other favorite method for showing multiplication and division. So let's do this same problem with caterpillars and show how I can do 6 times 3 with caterpillars. I'm going to start by drawing a caterpillar that is 3 units long. So instead of drawing a flower that has 3 petals, I'm going to draw a caterpillar that has 3 feet or 3 inches or 3 caterpillar units of length. So now instead of counting petals, I will be measuring length. So let's draw a caterpillar that is 3 units long. Do you see the 3 units? 1, 2, 3. So I shall draw that caterpillar. Okay, we have a caterpillar that is 3 units long. This first number is going to tell me how many caterpillars. So how many? Just like before, we asked how many flowers. Now I can ask how many caterpillars in this multiplication expression? 6. So far I have 1. So let's keep going. 2, 3, 4, 5, 6. Those are the antenna. Okay. And remember, each of these caterpillars has a length of 3 units. So from here to here, that's another 3. 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 And from here to here, another 3. In total, the length of this entire group of caterpillars is 18 units, whether it's inches or feet or miles if they're gigantic caterpillars that are 3 miles long each. Either way, the value of 6 times 3 is equal to 18. No. There we go. Okay. I wonder how we could use that same reasoning to multiply something like this. Now, instead of multiplying 6 times 3, I am multiplying 6 times 3/10. This number right here is a decimal. The decimal number can also be written like this: 0 decimal point 3. And since this 3 is in the tenths place, we call this 3/10. As a fraction, I could write it as this: 3/10. 3/10. That is that place value. Okay, what would this look like with my flower model? First, I need to draw a flower that has this many petals on it. Well, that's interesting. Okay, so let me draw a flower. And then I need to draw 3/10 of a petal. Well, 3/10 is less than 1. So let me do the outline of 1. Maybe let me outline 1 petal. So like, that would be 1 petal. That would be a flower with 1 petal. But this problem says we need a flower with 3/10 of a petal. So if this is 1 petal, 3/10 of a petal, one way I could think about that is by cutting this petal into 10 equal pieces. So I'll chop it there. I'll chop it here, 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 and here. Now, of course, these are not precisely equal. I'm trying to make it better by making them wider. So if this is 1 petal, and I've broken it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts, each of these parts is 1/10, or 0 decimal point 1. So in order to have a flower that has 3/10 of a petal on it, I can color in 1/10 of the petal, 2/10 of the petal, and 3/10 of the petal. This piece is 1/10. This piece is 1/10. And this piece is also 1/10. So together, this flower has 3/10 of a petal on it. It's less than one whole petal. It's 3/10 of a petal. What would it look like if I had 6 of these flowers? If I had 6 of these flowers. Can you picture it? This is 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. I'm going to draw my imaginary petal on each of them. Gotta draw the stamen. Mustn't forget. Okay, so here's 1. Here's 1. 1. We have that one there. Here's 1. Here's 1. Okay. First, I'm going to chop them all in half. Then I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's leaving 10 pieces in each petal. Okay. So now let's color in 3 of each of these. Each of these flowers has 3/10 of a petal on it. Just like this one, this has 3/10. This has 3/10. This has 3/10. This has 3/10. And this has 3/10. When you total this up, how many do you have here? If I wanted to think of this all together as one number, let's count how many tenths we have. 3/10, 6/10, 9/10, 10, 11, 12/10, 13, 14, 15/10, 16, 17, 18/10. So this answer can be written as 18/10. What? How do I get a fraction? Don't freak out. Each of these is 1/10. Altogether, they make 3/10. Another way to write 3/10, besides decimal form, is fraction form. So this is 3/10. 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 And this is 3/10. Okay. Altogether, I have 18/10. That would make one whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these together would make one whole petal. And then we would have 1, 2, 3, 4, 5, 6, 7, 8 left over. So 1 and 8/10 is our answer to 6 times 0.3, or 6 times 3/10. That's really interesting to me because over here, when we did 6 times 3, we got 18. And when we did 6 times 3/10, we got 1 and 8/10. I'm noticing that the digits are the same. There's just a decimal point. And that relates somehow to the numbers I multiplied. When I did 6 times 3, there was no decimal point in between my digits. I had 10 and 8. Over here I have 1 and 8/10. Interesting. Interesting. Let's try a different calculation now. What happens if I were to do that same question all I did was add a 0 in the ones place. It's the same question, I promise. There's 6 times 3/10. So if I were to do this with caterpillars, I would start by drawing a caterpillar that is 3/10 of a unit long. I'll just label that as 3/10, and then I would draw 6 of them. So here's 3/10. Another 3/10. Do you see how this looks remarkably similar to our diagram for 6 times 3? The only difference is now, instead of 6 caterpillars that are each 3 units long, we have 6 caterpillars that are 0.3 or 3/10 of a unit long. And just like with our flower example, when you total this length up, you get a total length of 1 and 8/10. So our value is still 1 and 8/10. That's really interesting. Very, very interesting. That does make me wonder. We did 6 times 3. We did 6 times 3/10. What would 6/10 times 3 look like? Could we do this? Of course we could. First, let's draw it with flowers. Just like in our first 2 examples, I'm going to use the second number and use that to represent the first flower. So I'm going to draw a flower that has 3 petals. I want some space, so I'm going to make it go to the right, this flower. Okay. Starting off wonky, but that's okay. No mistakes. Just happy accidents. Okay. So again, now I'm going to have 3. There's 1. There's 2. And there's 3. Empty space. So that's one flower that has 3 petals on it. Maybe I should underline that with blue. Now my first number here tells me how many flowers I'm going to draw. Well, this says 6/10. Again, the 6 is in the 10ths place. So the number 6/10 can be written this way, or it can be written this way. They mean the same thing. So when I see this decimal, I can think of 6 out of 10 pieces of something. So I'm going to take 6 out of 10 pieces of each of these petals. So let's take 6/10 of this. I'm cutting this into 10 pieces, and I'm going to shade in 6/10 of it. 1, 2, 3, 4, 5, 6/10. I'm going to do the same thing over here. 1, 2, 3, 4, 5, 6/10 of that. And then I'm going to shade in 6/10 of this. because instead of having more than one flower here, I have less than one flower. So I don't have 2 times 3. I don't have 6 times 3. I have 6/10 times 3. So I took my flower that had 3 petals, and I took 6/10 of each petal. That means I have 6/10 of the whole flower. Let's count up how many we have. Each of these pieces is 1/10. So here we have 6/10. Here we have 6/10. And here we have 6/10. This looks remarkably similar to when we wound up doing 3 times 6/10. So we have 1 8/10. Wow. That's really cool. It does make me wonder, though. So when we did 6/10 times 3, we got 1 8/10. And when we did 6 times 3/10, we got 1 8/10. So these had the same value. I need to make a list of what we've calculated so far, because there's some patterns emerging here that I really want to make sure we notice. When I did 6 times 3, my answer was 18. When I did 6 times 3/10, my answer was not 18. My answer was 1 8/10. And when I did 6/10 times 3, my answer was not 18. It was 1 8/10. I'm noticing a pattern here. And in case you're wondering why these numbers don't have decimal points, we usually don't write them, but I can write them here, here, and here, here, and here. All of these numbers have decimal points. Some numbers have them after the last digit. Some numbers have them before the last digit. Normally, we only write them for numbers less than 1. This makes me wonder, though. What would happen if we did 6/10 times 3/10? I predict, based on these patterns, that our answer would not be 18. I also don't think it would be 1.8. I think it would be 1800ths. And I'm curious if we could prove that. Let's say 6/10 times 3/10. If you're with me this long, I really, really appreciate your time here. And I also hope that you are proud of yourself for how much you are investing in your own mind and learning, and that you are taking the time to think slowly about things that a lot of people look for a quick answer to. I'm going to draw a flower that has 3/10 of a petal on it. So let's do that. Here's my flower. 3/10 of a petal. We've done that already. That was when we had to draw one whole petal and then split that into 3/10. Okay. Oh no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It never happened. What I did there was I broke my petal into 12 pieces, which would have made it hard to shade in 3/10. So instead of breaking that up, I'm going to re-sketch. I counted 5 instead of counting 4 lines. So that cuts my petal into 2 pieces, into halves. And then 1, 2, 3, 4 lines makes 1, 2, 3, 4, 5 parts in each group. And I'm going to color in 3 of those. Let's get some new colors in here. Let's do 1/10, 2/10, 3/10. Okay, let's make sure these are nicely colored in. There we go. Okay. Now, this problem doesn't have 6 flowers with 3/10 of a petal. It has 6/10 of a flower with 3/10 of a petal. So that means I have to take what I have here, and I only want 6/10. Another way of thinking of that would be 6/10 of this piece here. So let's think of this whole thing as 3/10. Let's think of that as one piece right now. I know it's 3/10 of a petal, but let's just think of this now as one orange shape. I wonder if I could cut that into 10 pieces. How could I do that? Well, I could cut each piece into 10 pieces. So let's cut this piece into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 pieces. Let's cut this piece now, and we'll shade in 6 of them. Okay. 1, 2, 3, 4, 5, 6. Okay, so that is 6/10 of 1/10. Whoa. So that is 6/1000ths, I think. Yeah, because this piece in black is 1/10 of a petal, and I cut that into 10 pieces to shade in 6 of them, so I'm left with 6/1000ths. Okay, so if I do that 3 times, oh my goodness, let's do that here. Let's break this piece into 10 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Each of those pieces is 1/10 of 1/10, which is 1,000th. So that's 1, 2, 3, 4, 5, 6, another 6/1000ths. If you're not sure why it's 1,000th, there are 10 here, 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 which would make them hundredths. Wait. If you're not sure why they're thousandths, you're correct. So let's write this a little bit more neatly and legibly. See how I just was able to check my own math by thinking slowly? That's the beauty of doing math in a way that makes sense to you, because you can always go back and check yourself. So I'm going to take this and break it into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to color in 6 of them. 1, 2, 3, 4, 5, 6. That is 6/100ths of a flower. And now, all together, I have 6, 12, 18/100ths. added together, I have 18 hundredths. As a decimal, you could write that as 18 with the 8 in the hundredths place. Therefore, my theory is correct. Let's return to what we know. Six times 3 equals 18. 6 times 3 equals 18. 6 times 3 equals 18. 6 times 3 equals 18. Okay. I just wrote the same multiplication problem 4 times. Why would I do such a thing? Well, I'm going to show you something that we just discovered. We did first draw 6 groups of 3 and showed that that was 18. Then we did 6 groups of 3/10. And we learned that that was 1 8/10. Then we did 6/10 of a group of 3. And we learned, oh, well, if you take 6/10 of 3, you have 1 8/10 also. And finally, we proved that if you do 6/10 of 3/10, so if you take 6/10 of 3/10, you are left with 18 hundredths. This is where our rule of multiplication comes from. When you are multiplying decimal numbers, you will be taught to first multiply the numbers as if there is no decimal there. So 6 times 3/10 looks very similar to 6 times 3. You just need a decimal point. So the pattern that I want you to notice is that when I did 6 times 3/10, I got 1 8/10. When I did 6/10 times 3, I got 1 8/10. And when I did 6/10 times 3/10, I got 18 hundredths. Wow. Wow. If you do this enough times, you will be able to multiply decimals in your head following a rule. And the good news is, if you forget that rule, you can always go back to drawing your flowers or your caterpillars. Thank you so much for taking the time to learn about decimals with me. Have a great night.